The research paper under consideration examines the concept of algorithmic fairness in artificial intelligence, highlighting the subjective nature of fairness and its dependence on values, experiences, and identities. A meta-analysis of 139 papers reveals a US-centric perspective and a reliance on binary codifications of human identity, overlooking complexities in diverse global contexts. The study underscores the need for a paradigm shift, embracing a more nuanced understanding of human values and addressing limitations in research design choices. It emphasizes the importance of acknowledging and addressing geographic and cultural biases, as well as implicit norms affecting diversity and representativeness. The findings aim to inform future best practices in fairness research, focusing on dataset characteristics, author information, modeling choices, and the mitigation of limitations. This comprehensive understanding is crucial for developing genuinely representative, inclusive, and fair AI systems. This research paper conducts a meta-analysis of 139 papers from AIES and FAccT conferences to examine norms in fairness research. It focuses on dataset provenance, author information, model design decisions, and sensitive attributes. The study reveals that the U.S. dominates both author affiliations and dataset origins, with finance being the most popular dataset domain. Gender, race, and age are the top categories for sensitive attributes. A socio-technical analysis highlights the importance of understanding the complex interplay between technological systems, human actors, and their broader societal context. The analysis also reveals inconsistencies in labels assigned to sensitive attributes, such as race, age, and gender, even when papers rely on the same dataset. Most papers failed to provide definitions for sensitive attribute labels, with age being the most problematic. Papers often omitted information regarding the source of their labels, rarely clarifying whether the labels originated from third-party observation or self-disclosure. The study emphasizes the need for careful consideration of social constructs in future research. It highlights two striking patterns: a disproportionate bias toward the U.S. in both author affiliations and dataset origin, and a pervasive tendency towards binary formulations of sensitive attributes. This U.S. centrism raises concerns about the limits of global fungibility, as papers rarely acknowledged or addressed potential biases arising from the predominance of the U.S. in author affiliations and dataset origins. The paper underscores the necessity to consider unstated influences shaping algorithmic fairness research, including geographical, cultural, and implicit norms within the research community. These biases can affect the diversity and representativeness of conducted studies, ultimately influencing the technological outcomes of algorithmic fairness research. Here is a combined summary of pages 912. The authors conduct a meta-analysis of fairness research, revealing a prevalence of binary formulations of sensitive attributes, particularly in gender, race, and age. A Sankey diagram in Figure 4 illustrates the distribution of label formulations for these attributes across fairness studies, showing that gender is most commonly formulated as female, male, race as black, white, or African American, non-African American, and age exhibits more diversity in categorization but still tends towards binary formulations. Figure 5 provides a detailed examination of binary formulations for sensitive attributes, highlighting the most frequently studied attributes: gender, race, and age. The analysis raises important questions about the assumptions and limitations underlying fairness research, particularly in the context of sensitive attributes. The prevalence of binary formulations may oversimplify complex social realities, potentially leading to biased or unfair outcomes. The research highlights the biases and limitations in algorithmic fairness research, particularly in the context of US-centric norms and binary formulations of sensitive attributes. It argues that the field's outputs are influenced by American societal structures and legal frameworks, often at the expense of other cultural and social contexts. The use of binary labels oversimplifies complex social identities and ignores the nuances within these categories, erasing intersectional realities and positioning groups against each other. The study emphasizes the need for more nuanced and context-specific approaches to fairness, acknowledging the fluidity and complexity of identity. It stresses the importance of recognizing the historical and ongoing impact of US-centric biases in research design, data origins, and the definition of demographic categories. The authors suggest that a more inclusive and equitable research framework is necessary to address the diverse experiences of discrimination and promote truly fair systems. The current state of fairness research is critiqued for its limitations, specifically its US-centrism and binary logic, which restrict the scope of inquiry and exclude alternative perspectives, perpetuating the myth of algorithmic fairness as a fungible, abstract, and universal phenomenon. To overcome this, the authors propose charting new paths forward, guided by inclusivity, representativeness, and cultural specificity. Expanding the scope of inquiry to generalist conference venues, preprint repositories, and journals can enrich and contextualize our understanding of contemporary norms and practices in fairness research. A critical examination of social and structural factors shaping research practices across these sites can identify biases and encourage a more inclusive and representative vision of algorithmic fairness. Solutions proposed include prioritizing transparency and self-reflection, diversifying representation across datasets and research teams, and grounding research in real-world issues. The need to move beyond simplistic binary classifications and engage with the complex, intersectional realities of bias, identity, and community is emphasized. The paper's meta-analysis reveals a field grappling with fundamental tensions, including the tendency to default to US-centric perspectives and binary representations of sensitive attributes, which can compromise research credibility and lead to poorly aligned policy solutions. The authors, situated at the intersection of technology and marginalized communities, acknowledge potential biases introduced by their own identities and experiences, welcoming constructive engagement and alternative perspectives. The concept of unfair norms in fairness research is discussed, highlighting the importance of understanding biases and disparities in AI systems, particularly in the context of gender and racial identity. A nuanced approach to fairness, considering intersectional biases, is necessary, and participatory AI development involving diverse groups is crucial. The paper references critical race theory, data feminism, and socio-technical design principles to support its arguments, emphasizing the urgent need for a more equitable and inclusive approach to AI development and identifying areas for future research. The research paper explores the concept of fairness in machine learning, focusing on how societal norms and cultural context are often unfairly applied. It delves into the intersection of race, gender, and technology, highlighting the need for a nuanced understanding of these complex relationships. The authors emphasize the significance of considering cultural norms, the importance of global perspectives, and the need for fairness and abstraction to be considered together. The paper also discusses the limitations of current data-driven approaches and the importance of critical data studies and understanding cultural context. Additionally, it touches upon the role of fairness in pensions and social policy. The meta-analysis examines the norms in fairness research, focusing on the geographic distribution of authorship affiliations, study design, and algorithmic interventions. It reveals a consistent dominance of US affiliations, a preference for retrospective analyses, and a growing ambiguity regarding the trade-off between fairness and performance. The study highlights the need for more diverse authorship affiliations, varied study designs, and innovative algorithmic interventions to address fairness concerns. Here is the combined summary of pages 21-24. A meta-analysis of fairness research reveals a lack of diversity in datasets and fairness metrics used. Figure 7 shows that most papers engage in retrospective analysis of existing datasets and algorithms, with synthetic datasets being the most frequently leveraged. The COMPASS dataset is the most studied individual dataset, followed by the German Credit and UCI adult datasets. Figure 8 highlights the trends in intervention points and acknowledgement of performance trade-offs over time. In processing consistently emerges as the most common point for implementing fairness interventions, with an upward trend in the number of papers that do not address whether improving fairness metrics comes at the cost of performance. The prevalence of different fairness metrics is also investigated. Figures 9 and 10 illustrate the results, presenting the top 10 most frequently used metrics and the full list, respectively. Demographic parity consistently ranks high in popularity over the years. These findings suggest a need for more comprehensive and diverse approaches to fairness research, including the exploration of alternative datasets and fairness metrics. A bar plot in Figure 10 reveals a temporal trend in the adoption of fairness metrics, with certain metrics gaining popularity over time, while others experience a decline. Tables 2 and 3 provide a comprehensive overview of the sampled papers, enabling a deeper understanding of the research landscape in fairness metrics. The analysis aims to uncover patterns and biases in the adoption of fairness metrics, ultimately shedding light on the unfair norms that may be perpetuated in fairness research. The meta-analysis identifies the most widely used fairness metrics, as well as those that are underutilized or overlooked, and examines the temporal trends in fairness metric adoption, informing the development of more comprehensive and nuanced fairness metrics. The analysis provides a critical examination of the research landscape, highlighting areas for improvement and opportunities for future work in fairness research. Fairness in machine learning is a multifaceted concept that encompasses algorithmic biases, data biases, and transparency in decision-making processes. The need for fairness arises from the requirement for algorithms to be not only accurate but also unbiased, ensuring equal opportunities and outcomes for all individuals and groups. Biases in machine learning models can perpetuate and exacerbate existing social inequalities, disproportionately affecting marginalized communities. To mitigate these biases, mechanisms for detecting and addressing them are essential. Fairness is a domain-agnostic concept, applicable to various fields such as healthcare, education, and employment, where decision-making processes have a significant impact on individuals and communities. In healthcare, for instance, biases in diagnosis and treatment can lead to health disparities, while in education, biased models can perpetuate achievement gaps. Similarly, in employment, biased hiring algorithms can result in discriminatory practices. The authors emphasize the need for transparency in decision-making processes, enabling the identification and rectification of biases. This transparency can be achieved through explainable AI, model interpretability, and auditing mechanisms. Furthermore, fairness metrics, such as demographic parity and equalized odds, can be employed to evaluate the fairness of machine learning models. The research highlights the complexity of fairness in machine learning, underscoring the need for a nuanced understanding of biases and their impact on different domains. By acknowledging the importance of fairness and developing mechanisms to address biases, machine learning can become a more inclusive and equitable technology.